Welcome, here we are again with our LED driver design. We're getting pretty close to a final design here. As I said last time, I had to split it from a 4-channel into a 2-channel because of space constraints that I have in my use. So this is pretty much the final design. You might notice I managed to take this track here and pull it. Instead, it used to run up and across, and now it kind of goes around the outside. And that gives me very nice ground plane. I have pretty much a full ground plane in the back, which means I'm not sure I need all these vias anymore, but we're just going to leave them because they aren't harming. And I have a pretty nice wide VN coming across. So this design makes me pretty happy. So now the question is, how do I go and actually submit this, actually get this built? I'll talk about 2 different steps. First, we're going to talk about how to just get the PC board created, in case we want to do the soldering ourselves. And then I'm going to talk about how we get the actual assembled board created. And I'm showing you the flow for JLC PCB. The flow for anybody else who does just PCB creation is going to be pretty similar. The flow for assembly is going to probably be a little bit different for everyone who does it. Or at least the files might be a little bit different. So we start with these. And the first thing we need to do is go and choose plot. And we're going to create what's called Gerbers. And I don't understand why they're called Gerbers, but basically this is a set of descriptions of each layer in the printed circuit board. So you can see front copper, back copper, paste, silkscreen, mask, and edge cuts. And basically I'm going to create all these and then put them together and hand them off to the house that does the fabrication for the PC boards. And you can think of this as just the standard format. Now there's one thing that's a little weird with Gerber files is there is no standard for where you drill holes. That's part of Gerber. So you have all the Gerber files and you have the drill files. And we have to generate them separately. It's a little weird that way. But when people say Gerbers, they typically mean both the Gerber files and the drill file. So I usually go and generate the drill file first, simply because I don't want to forget. Okay, so generate glue. Okay, and now I do plot. And it said it created me a bunch of files. Close. So now I can go off, and well, I've done this before. But you notice all these .gbr files, and then there's the .drl file. So what I want to do is take all of these. I don't need that file. And put them in a zip file. And I usually call it that main thing. So this archive is enough to tell the house how to build the PCB board. So we'll flip over. Quote now. And it says, add your Gerber file. So here's the Gerber. Let's hope this worked. It was failing yesterday for me. And it's going to read in all those files, look at things, figure out how they're going. And with any luck, there we go. There's our 2 little images. Now they have a little Gerber viewer you can go through and look at. I recommend that you do that. Here's another thing that I would recommend. OSH Park is a pretty decent place for small things. They will do 3 boards pretty quickly. So I'll sometimes buy boards from them. They can be nice to use as kind of a preview of what you're going to get. So So give them an email. Normally I give them my real email. And then they give you these really nice views of what your board will look like. So go through all of these and see, just does everything make sense? Are your drills in the right place? Does the silk screen in the back? This is a view from the top. Does the copper look right? Does everything else look right? Does the bottom layer look right? Does the board outline look like right? Do the solder masks look right? All of that is really useful to look at ahead of time. So flipping back here, it's 2 layers. They grab the dimensions from the Gerber. You can choose a wide variety of numbers. We're only doing one design. It's a single PCB. If you can play around with these, some things are free. Some things cost more. So surface finish is HASL with lead, which is kind of a typical tinned one. There's this really nice Enig, but you'll see that went from $2 to $18. Or if we go with lead free, a little better. So how thick the copper is, whether you want gold fingers, what type material, all these other sort of things you can choose as your option. And at this point, if I wanted to just get it, I could just save it to cart. I could just save it to the cart and then go ahead and order it. And it would show up in, what are we saying, 15 to 25 days. And this one's a $2 JLC PCB has for small prototypes. They have a really good deal. You can find other places. I'll show you something in a second. And about $5 shipping. If you're going to do PCBs only, you should go to PCBshopper.com. And this one, you need to know the board size. So it's 33 by 22. So 33 by 22 millimeters. Let's just say I want 10 of them. And ship to all these different things. And you can do get prices. And this essentially goes out and looks at a whole bunch of different options. And you can see that you have, we actually don't have the special one that we were seeing on JLC PCB, but you can just see lots of different options. So all PCB, which I used for a while on some other stuff, if you want, and it lists where they are. So if you want things in the US and you want them really quick, you might use options down here. So this is very nice if you're just shopping only for PCBs. If you're shopping for assembly, here you'd have to know 5 unique parts, 5 SMT parts, 0, 0, I don't know, 25, 0, 0. So roughly number of through-hole pads. Some. And then they give us some prices too. So you can go and use this and try to get some idea of how much things are going to cost you. And you notice it lists PCBWay and all PCB are actually pretty cheap here. But the disadvantage is you may have to send them your components or ship them your components. And that's a different way of doing things. It may end up being cheaper, may end up being more of a hassle. So anyway, those are your options. PCB Shopper is really good. So if I wanted a board, I could just go off and do that. If I want assembly, I like this free assembly. Well, it's not going to be free. Okay, so surface mount assembly. The assembly JLC PCB does is only on one side. you can't put stuff on the back. So I have to say I'm going to put it on the top, which is fine. I have no components on the back. For quantity, I can do up to 5. I think they support up to 50 total. Tooling holes, we're just going to leave that. So we're going to go off and confirm and say, okay, we want you to do assembly. I'm not sure why I got that twice. Okay, so it's asking for 2 things. BOM, a bill of materials, and CPL. I don't know what CPL stands for. So we can get those from KiCad. So if you go and look, JLC PCB has a help page that talks about what they want for their files, for both of those file formats. And they point you to a spot, and then there's actually this little generate bill of materials here. And they will point you to this little plugin that you can download. And then basically what it's doing is it'll take the description of your components, it'll create an XML file, and then it's going to run an XSLT, an XSL transform on that to get it into the format that they want. So generate the XML, then run the transform. Unfortunately, the XML generation, well, that works fine for me, but whenever I try to use this, it gives me error code 11. And I've looked online and tried the things that say you should do these things to fix it, and they don't work. But luckily, I happen to know just a little about XSLT. And we're going to use the Microsoft XSL transformer rather than the one that comes with KiCad. So basically what I did is I created a little batch file. So run the transform, send the output to this CSV file. The input here is the XML file that they created when I did that. And then this is the transform to use. So I run that, and it took the XML, transformed it into another XML, CSV. And we can look at that. Not very surprising. So C1 and C2 are 33 microfarad capacitors. And this is the footprint, and this is the part number. So really not much of a surprise there. So I can use that as the bill of materials file. Okay, go there, open up. Okay, so that tells the assembly house what components I want on the board. But it doesn't tell them where to put them and how to orient them. So that's what the CPL file is for. And this time we need to go back to the board editor, choose File, Fabrication Outputs, Footprint Position. And here I have it going to Gerbers, it could go anywhere else. So I generate the position file. That worked okay. Now, this is a case, if you're reading their instructions, the file it generates isn't quite right. So this is the file that it creates, and the file is fine. Unfortunately, the header names are not correct. Now, why they don't actually change their code to support, because KiCad gets used all over the place. Why they actually don't support this, yeah, I don't know, but they don't. So basically we have to replace this header with the names they want. So I save that. Now we can add that file in. That's in Gerbers. It generated both the top and the bottom one. Since I'm only assembling the top, obviously I only need the top. Okay, now it has both those files. And now let's see what happens. It did next. So what it did is it went through the bill of materials and it essentially just parsed it. So we can see our resistors. These are what I'm expecting. This is the footprint. This is the part from their parts database that they matched. So you want to go through and make sure that these are really the parts that you want. You can see their extended parts, the quantity, how much they cost, and the quantities we're buying, and then confirmed. And confirmed means that they actually have it in stock. So earlier, where I had to change capacitors, I went through the first time, it was confirmed, and I came back a couple days later and they were out of that part. So it'll tell you something different. So next, now, here's the exciting part. This is what the board would actually look like. So nice little board preview. I have an inductor, capacitor, resistor, diode, and then the driver itself. So, and it tells us what the parts are. It tells us what unselected parts there were. Now in this case, I have the two output jumpers and the power. I mean the output headers and the power header. They came across in the file, and they aren't selected for assembly. They don't do, JLC PCB doesn't do through-hole assembly, and that's just fine with me because I don't need the headers. And we see, what does this cost? Well, special offer, $4. Setup fee, so you pay $7 just to have it set up for assembly. You pay $1.50 for the stencil that they are going to use to put the solder paste on. So it has holes, wherever I'm pointing, we have a pad, and we're going to want solder paste there, so the stencil has those. Panelization. I assume that's panelization, means putting them all together. They didn't charge me for that. Components, this is the actual charge. So for 5 of these boards, the components would cost $10.34. Extended components fee. So what does it say? Extended components are required to change the feeders on pick and place machines, which requires an additional labor fee. $3 per extended component. So every component I have is an extended component. Therefore, $15, and think of it kind of as another setup fee, or an extended setup fee, I guess. And then they charge me a total of 30 cents for the machine time on the pick and place, which is essentially nothing. And so build time, 2 to 3 days to make the printed circuit board, 72 hours. I really like that this is in days and this is in hours. So 2 to 3 days, but 72 hours. Total price, $38.13. So, and I went and looked at this. So it was $38.13, and I think the shipping was like another $15. You have your choice between fast shipping that you kind of trust, or slow shipping that may not get here. And I've noticed that the prices they charge for assembly shipping are a fair bit more than the prices they charge for PCB shipping. But I will say the JLC PCB stuff is pretty nicely packed, whether it's PC boards or assembled boards. So that means overall for 5 of these, I'm talking around $50, in the low 50s. I went and looked, what would it take for me to do this myself? If I bought those parts from LCSC and had them shipped to me, they would be about $16 shipped, and they'd take from 2 to 4 weeks to get here. So considerably less than getting them assembled. And then the circuit boards, shipped would be about another $7. So it's basically $25 to get the boards and the components and do it myself, or $50 to get them myself, to get them all assembled. And wow, I'm cheap, so that's really right on the edge, and I don't know which way I'm going to go with this board. I will say, you notice a lot of our costs here. We had a setup fee, and we had an extended components fee. So a lot of our cost here is fixed. And if we went up, that's for 5. If I wanted 50 of these, my guess is for 50 of these, it's going to be pretty darn close in per board price to having them assembled versus doing it myself. So for small amounts, I don't know yet. The difference between 25 and 50 is not that great. And I'll probably just order it just so that I can save myself some time and save myself some hassle. The downside, of course, is if you've made mistakes, then things are not going to work very well for you. Oh, one more thing I should say. So if you want review for this, there are a few things you could do. Reddit has a subreddit called Printed Circuit Board, where you can send them a design, an image. I'd send like this image. I'd probably send that image too, along with a description of what the board is going to do, and ask for a review, and people will look at it and generally gives you some pretty good advice. The other thing is you can go File, Print. And what that is going to do, choose what layers you want. Okay. I don't think I want that view. Let's go back. Okay. So here we go without the copper layers. Okay. So print this out. This is what your board will look like when you get it back. And it will be pretty close. Okay. Pick scale 1:1. That will be pretty close to the exact size. So what you do is you print this out, and then you take the components you have and you lay them down physically on top of this and see if they fit. Now this obviously requires you have components first. But if you do that, the chance that you make a mistake is considerably smaller than the chance that you do things later. So that's about all I wanted to talk about. So I took the design and submitted it, or I will probably submit it pretty soon. And we'll just see what happens. In a couple weeks, I'll have boards back, and maybe I'll show what comes next. Thanks for listening.